Hello students, today we are going to see exercise 1.2 sum number 1. Sum number 1 has 5 subdivisions. Okay, so we are going to see that alone. Right, in this exercise we are going to see some basic relations. You know what is a relation, you learnt in 10th standard. We are going to see some basic relations like reflexive, symmetric and transitive. So how to check all these relations, and finally we are going to see what is equivalence relations also. Right, now we'll get into it. Let S be a non-empty set. So S is a set must contain at least one element. Okay, it's supposed not to be a empty set. Okay, it should be a non-empty set. And let R be a relation. What is relation means? We have to make a set R. How to make set R means taking elements from set S using some condition. Okay, that is a relation. Okay, so that we will see in example, you will understand very easily. First you keep that in mind. S is a non-empty set. So from that set, taking elements, we are framing another set which is called R under some condition, that is relation. And then I told that three basic relations are available. One is reflexive. R is said to be reflexive if A is related to A, that is A R A. A is related to A for all A belongs to S. That means every element in set S must be related to itself, that is A is related to A. Okay, all the elements must be related to itself means then we can say it is reflexive. Secondly, symmetric. R is said to be symmetric if A is related to B and B is related to A. So if there is an element A is related to B, then only you have to check for B is related to A or not. If there is no element A is related to B, means you don't want to go for B is related to A. If A is related to B is available, then you check for B is related to A. If it is true, means it is symmetric. If not, it is not symmetric. Third, R is transitive. So here first two conditions. A is related to B, B is related to C, then A is related to C. Okay, I'll repeat it. A is related to B, B is related to C, so A is related to C. So A or C. Now here, if the first two conditions are available only, then we can go for the third condition. If the two conditions are not available, at least one is there means, or both the conditions are not available means you don't want to go for the transitive condition. If two are available and the third condition fails, you can say it is not transitive. If three are success, you can say it is transitive. Right, now then we can go for equivalence relation. If the three relations like reflexive, symmetric and transitive are true, we can say R is equivalence. If any one of the relation fail, you can say it is not equivalence. Okay, so you might have got some idea. Right, now once get into the problem, you can easily understand the sums. Okay, right, now first you see, discuss the following relations for reflexivity, symmetricity and transitivity. Sum number 1. The relation R is defined on the set of all positive integers by M or N if M divides N. Okay, so now we are going to make a relation R from the set of all positive integers. What is the relation means? M is related to N if M divides N, that means N is divided by M. Okay, now I'll show you how to check this. Now first we have to take three elements belongs to the given set, that is M comma N comma P belongs to the set of all positive integers. Now first we have to check for reflexivity. So reflexivity, I told that all the elements in the set must be what? Related to itself. Okay, so first we will say M divides N, isn't it? Condition is division, isn't it? So M divides M, that element divides itself, means we can say it is reflexive. isn't it? So m divides n means if m is divided by m, it is equal to 1. So all the positive integers, that means if you take all the positive numbers one by one and divide that number by itself, you will get only 1. So we can 1 is what? 1 is a positive integer, isn't it? So whenever you take all the elements and divide by itself, the answer is 1, which is a positive integer. That means the relation is true. M is related to m. So we can say R is reflexive. Okay, right. R is reflexive. Now we'll get into the next property. Okay, so what is the next property? Is symmetricity. Symmetricity means what? I told one condition. A is related to B. Here m, n we have taken. So first we'll say m is related to n, m or n. It means what? M divides n. That is, n is divided by m. If you divide n by m, any number, any set of numbers, divide by m, you will get one answer. So if you divide a positive number by a positive number, you are getting a answer. So that is the condition already given. So when you divide a positive number by a positive number and you are getting a positive number, so that is the condition already given. Secondly, we have to check for the reverse, that is symmetricity. So what is the reverse condition means? That is n divides m. Okay, n divides m. So n is divided by m is divided by n. So m is divided by n is, it's a reverse. What is the reverse? It is nothing but 1 by k, isn't it? If m divides m is equal to k means m divides n is equal to what? 1 by k. 1 by k is a fraction. It is not an integer. So this condition fails. So m is not related to m. Okay. So it is not related. See, I have given here, this is n is not related to n. So you have to write that with a small striking symbol over the r. So n is not related to m. Now we'll go for the next property. So this is not symmetric. Then transitivity. So coming to transitivity, m or n, the condition already given. It means when you divide n by m, you will get a positive integer. So let that be k. Okay, so I have taken the m to the right hand side. So n is equal to mk. Can you understand? So n is equal to mk. Now next one is a second condition is also given in the question. Okay, what is the second condition means? We have taken p, isn't it? So n is related to p. That is also given in the condition. Okay, so n is related to p. So n divides p. So p is divided by n. Okay, so p is divided by n. So that is also a positive integer. So taking this n to the right hand side, so p is equal to nl. So this is taken as equation 2 and previously we had taken as equation 1. Right, now what I'm going to do is I'm going to substitute the okay, now substituting 1 in 2. Okay, this 1 is substituted in 2. So in the place of n, this mk is substituted. So p becomes mkl. Okay, right. So bring this m to the denominator. So p by m is equal to kl. What is p by m? That is the third condition we are supposed to check. So what is the third condition? M divides p. So m divides p means m or p. Okay, so m or p is also an positive integer, isn't it? K is a positive integer, L is a positive integer, product of two positive integers must be a positive integer. So the third condition is also satisfied, so it is transitive. Okay, right. Now we'll get into the next problem. Discuss the following. Relation is reflexive, symmetricity and transitivity. Subdivision 2. Okay, so here we are going to take a set P that set contains all straight lines. Okay, all are straight lines. Now we are making a relation. How we are making a relation means L is related to M if L is perpendicular to M. Okay, so one line is that means one line is perpendicular to another line. So we are going to take 3. things like L, M, N belongs to the set P. First we'll check for the reflexivity. So how to check reflexivity? L is related to L. So what is the relation? Relation is perpendicular. Okay. So L is perpendicular to L. See, I have given a line here. Is this line is perpendicular to itself? No, it is not perpendicular. So it is so the condition is failed. So R is not related to R. So it is not reflexive. Secondly, we have symmetricity. So symmetricity, L is related to M. Okay, so I have taken two lines. So now first condition we must take as given. So see, L is perpendicular to M. Okay, so line L is perpendicular to M. So now we have to go for the reverse, isn't it? Whether M is related to L or not. So M is related to L or not. M is perpendicular to L. If L is perpendicular to M means M is also perpendicular to L. From the diagram itself we can say that. So this property is also true. So symmetricity, R is symmetric. Now we'll go for the transitivity. Coming to the transitivity, we have to check for two conditions. L is related to M. So it is already given. So I have given in the diagram, that is L is perpendicular to M. See, this is L. So L is perpendicular to M. Right. So now M is related to N or not, so that we have to check. So M is related to N. So I have to take one more line that is perpendicular to M. Okay. So now see, now here you can check that M is perpendicular to N. This is also must you have to take. So that is taken. Now the third condition we have to check and we have to prove it. That is what? M, L and M. So we check L and M. Okay. So L is not perpendicular to M. Why? L is parallel. See, when you check, L is this line and this line are parallel lines. They are not perpendicular lines. So the condition failed. So here L is not related to N. So what happens? Transitivity is failed. So R is not transitivity. Now we'll go for the next subdivision. A is set of elements, that is all members of a family. A set contains all members in a family, like father, mother, sisters, brothers, like that. You can have a grandmother, aunt, uncle, like that. Okay, so here we have to check for a negative statement. Okay, that is not a sister. Okay, not a positive statement, it is a negative statement. So not a statement, not a sister. So A is related to B only if A is not a sister of B. Always keep that in mind. When you make the statement not, then only the property is true. Okay, so a little bit confusing. Okay, now we'll get into it. A comma B comma C belongs to the set A we have taken. Now we have to check for the reflexivity. So reflexivity means what? A is related to A or not, we have to check it. Okay, so A is related to A. How we can check it means we can take element A and we can check whether it's a sister or not. Suppose if you take women, maybe a mother. Mother is not a sister to mother, isn't it? Father is not a sister to father. All you can take all the member, any member in a family, that member is not a sister to it's herself or himself. So this property is, this reflexivity is failed. Okay, right. But here the condition is we have to say it is not. If it is not sister only, the property is true. So A is not a sister to A. That means all the members in a family is not a sister to themselves. So that is what we have to prove. Since we proved that, what is reflexivity is true. So R is reflexive. Okay, A is related to A, R is reflexive. Coming to the symmetricity, A or B we have to take as it is. So A is not a sister of B. Okay, so if any one condition B fails, means we can say symmetric, it is not symmetric. So I'm trying to fail this property. So I have taken A as a brother and B as sister. Okay, brothers and sisters, sibling. So if you put you just read as it is, A is a brother. So brother is not a sister to a sister, isn't it? A is a brother. So in the place of A, you just replace brother. So brother is not a sister to B. Okay, isn't it? He is a brother to B. So here this is a correct statement. Then we could go for the reverse. How will go for the reverse? B is a sister of A. Isn't it? B is a sister, A is a brother. So B is a sister of A. But here we have to prove what? B is not a sister of A, which is failed. Okay, so symmetricity is wrong. B is not related to A, so R is not symmetric. Now transitivity, first condition, A is related to B. So A is related to B means A is not a sister of B. Here I have taken A and C as sisters, and B is a son of A. A and B are sisters. So B is a son of A means A is a mother of B. Then who is C? C is a aunt to B. Okay, right. So A is not a sister to B, right? No, because A is a mother of B, right? So this condition is true. This relation is true. Second is B is related to C. Who is B? And how B and C are related? B is also a son to C, or you can say C is a aunt to B, isn't it? So they are not sisters. Okay, so B is not a sister to C, so this is also true. Now coming to the last one, how A and C are related. A and C are related as sisters. The A is a sister to C, isn't it? So this condition, here we are failed to prove this property, this relation. So A is not related to C, which is not transitive. Now coming to the fourth subdivision, same thing, but we have to take all the female members of the family, not all the members, only the female members, and we have to check the same relation, like same condition. The first one, we'll take A comma B comma C be related to A. Now reflexivity. So first condition is like A is not a sister. The same thing, all the member in a family is not a sister to themselves. So first condition failed. So A is not related to A. So it is A is not related to A, that is A is not a sister to A, so A is related to A, it is reflexive. Then we have symmetry property. Symmetry property, previously we have taken brother and sister. Here we cannot take brother and sister because female members. So all are you can take only female members. So suppose if you take first condition, we must take her in a correct way, isn't it? That is if A is not a sister, means the reverse is, if you take two members as sisters only, the reverse will also be true. If you take two members as not sister, then the reverse is also not sisters. So you don't want to prove it like that. So you can directly say that if A is not a sister to B means naturally B is not a sister to A, because here there is no male members, all are female. So we can say that it is symmetric. So B is related to A, which is symmetric. Now transitivity. Now coming to transitivity, first we have to take A is related to B. So here I am going to take A and C are sisters. Previously we have taken son. Now here B is a mother. That means A and C are sisters. Now B is a mother of A. Naturally B is a mother of C also. Okay, that means grandmother, right? B is a grandmother, and A and C are B is a mother, and A and C are daughters. Okay, B is a mother and mother has two daughters who are A and C. Keep like that. Okay, now we'll check that. How is A and B are related? A and B are related. That means A is a daughter to B. So A is not a sister of B. So this property is true. Now B is related to C. How we have to check that? How is B and C are related? So B is a mother to C, isn't it? So B is a mother to C. So B is not a sister to C. So this is also true. This property is okay. Then we have to check the main condition whether it is true or not. That is relating A and C. Relating A and C. So A and C is sisters, isn't it? We have seen that. So here transitivity is failed. So A is not related to C. So which is not transitive. Now we'll get into the last subdivision. On the set of natural numbers, the relation R is defined by X or Y. X is related to Y if X plus 2Y is equal to 1. Okay, so first we have to take a natural number from the set and another natural number by multiplying the natural number by 2, adding that you will get 1. Now you see here in this problem, X is greater than 1, isn't it? Because X is a natural number, and that means element, the set is a natural number set. So X, if I take an element as X, means that number must be greater than or equal to 1, because natural number starts from 1, so it must be greater than or equal to 1. Same way I'm going to take another element that is also greater than or equal to 1 or 2, 3 or goes on. So the two elements belongs to the natural number. The two elements are greater than or equal to 1. So when you add two natural numbers, what will happen? See, I will given in the bracket, so you just check that in the bracket I have given, say I have taken X as 1, Y is also 1. These two are the minimum starting natural number. So 1 plus 2 into 1, which is 1 plus 2. 1 plus 2 is what? 3. 3 is greater than or equal to 1. Right? So even if I take the minimum number, that is the natural number 1 and apply in the condition fails, because that must be equal to 1 they asked. So it is not possible. When you take two natural number and you can put into this condition, it is greater than 1. Minimum is 3. When you take 2 means it is greater than 1, 3, 4, it is keep on increasing. So all the element is failed here. If you take any element in the natural numbers and you can apply in the condition, you will not be getting any number. So it means the relation, the set R, we are to find the set R. Set R is empty, isn't it? No condition. So all the condition failed. We cannot take even a single element from the natural number set to frame the R set. So R set is empty. So there is a note given in your textbook. What is that? In illustration 1.4.6, they have given that an empty relation can be considered as symmetric and transitive. Suppose a set relation is empty, you can easily say it is symmetric and transitive. How means? I told that in the beginning itself. If in the symmetric there is a condition, first condition, if there is a condition, first condition is there, then we can go for the checking, then we have to check the second condition. If there is no first condition itself, you don't want to check the second condition, so it is symmetric. And in transitive also, if exist two conditions, there exist two conditions, then only we can check for the third condition. If the two condition is not available, why we have to go for the third condition, right? So here it is transitive. So an empty set is always symmetric and transitive. And you can from this we can say that R is an empty set, so R is not reflexive, but it is symmetric and transitive. Okay, so that's all. Thank you.